All right. So let's have a look at this integration question that we have to do here, which is telling us find the exact value of the integration between 2 and 1 of ln 3x dx. Give you answer in the form of a plus ln b, where a and b are integers. So by looking at this question straight away, we have to integrate this, and we might be thinking, okay, what type of integration do we have to do here? So there are various different techniques. I already give a hint here. So if you if you couldn't connect the dots already, in this case here we have to use integration by parts. So you'll be like, okay, there's only one term though, ln 3x. Of course, that is correct. However, what we can do to this is we can rewrite this as integration between 2 and 1 of 1 times ln 3x dx. So now we have two values multiplying together, the 1 and the ln 3x. And therefore we can break this down in our u and our dv over dx and find the corresponding value and substitute them back into the formula to do it. By the way, if you do not remember the formula, it's not big worry. It is provided in all exam boards and in all exam board in the formula booklet. So without further ado, let's get started with this. So that becomes u is equal to our ln 3x, and our dv over dx will be our 1. Some students always ask me, sir, how do you know which one is our u and which one is the dv over dx? It could work with both ways, but however, if one of the method doesn't work, in one of the way doesn't work, so in this case where I'm letting my u is equal to ln 3x, then I can always switch around to try the other method. But always try to pick the way that it looks like the easiest way to differentiate and integrate. For example, it is a lot easier to integrate. Well, in this case, there's only one way to do it, because dv over dx can only be integrated when it is 1 and not when it's ln 3x. Otherwise, we'll have integration by parts within integration by parts. So our u is ln 3x, so let's do du over dx. Du over dx is going to be equal to ln goes straight as 1 over 3x times this is the way we're applying the chain rule, the differentiation from inside the bracket, which is only a 3. And from there, we can simplify this down to as 1 over x. Our dv over dx goes from dv over dx as v is equal to as x. In this case here is we have an x to the power of 0, so we're increasing the power of x by 1, dividing by the new power, which gives us x. And there you have it. Most of the hard work is already done. So now it's just all about substituting and making our life easier. So this is the part that we worked on until now, and now it's just about substituting into there and making our life as easy as possible. So we're multiplying our u times v, so it's we're not going to have the integration sign anymore because we can integrate it already, so we just have to substitute into the values. So in this case here, if you're substituting into the value, that becomes u times v, so our u is ln x, our v is x, so it becomes x times ln 3x minus integration of v du over dx. So our v is x and our du over dx is 1 over x, so it becomes 1 over x times x with respect to x. And then all of that can be put into brackets where the limits are 2 and 1. So from here, now there's nothing to simplify at the beginning, so that stays as x ln 3x minus, in this case, the x and the x cancel out, so that becomes integration of simply 1 of with respect to the x. So we still have the values, so let's integrate this fully. So that becomes x ln 3x minus, same thing as before, we have integration of 1, which is again going to be x, and now we can put our limits as 2 and 1. So this is a fully integrated answer, and now we have to find out the value of this integration by substituting in the limits. One of the ways that students would do mostly is try to put this straight into the calculator, but again, I want to remind everyone that in this case here, they told us to giving us the answer in terms of a plus ln b, so therefore we should try to substitute manually and break that step down. I'm going to use square bracket to represent the two limits. So the first, I'm substituting the 2, so x is 2, so 2 times ln 3 times 2 minus 2. That's my first part where I substitute into the value, minus, I'm substituting the 1 now, so it becomes 1 times ln 3 times 1 close bracket, minus 1. So it's very important to put this in brackets because you have a minus here. So sometimes you have a minus and a minus, and that becomes a plus. If you have the brackets, it really separates those things out of it. So now, if we simplify this further, that becomes 2 ln 3 times 2 is 6 minus 2. Again, I'm going to use brackets, minus ln 3 minus 1. So now what we can do is we can bring the ln's together. So that becomes, before we bring the ln together, let me take the 2 as a power. So therefore it becomes ln 6 squared minus 2 minus ln 3 minus 1. So from there, that becomes ln of 36 minus 2 in one bracket minus ln of 3 minus 1. And from there, I can bring this down together. So I can bring down the ln together now using the ln's property. So if you have ln 36 minus ln 3, I'll put it in a bracket, and then we have minus 2, minus 2, and then minus and minus makes a plus as the other bracket. In this case here, if you do that, so the ln's become together, and if you use the ln lows, so that becomes ln 36 divided by 3 minus 2 plus 1 gives us minus 1. So ln 36 divided by 3 gives us ln 12 minus 1, and therefore that will be our final answer. So if you rewrite in the same format, so that become minus 1 plus ln 12. Was this many steps needed? Maybe not, but here I'm trying to break this down in the simplest way possible by breaking it down step by step, so there's nothing that confuses you. We all know that the Mars games like to skip steps, so I'm trying to break it down every step by step, so that way there's nobody that is lost what's happening. Any question, please do let me know in the comment below. Thank you.